Okay, now there are lots and lots of questions, so we'll invite Vikram and Emelia and James to take a seat. Can I kick off? We're talking here about hydrogen directly into appliances. Can you mention a little bit? I know that CSIRO, for example, is looking at transporting hydrogen as ammonia for various purposes. I know there are fuel cells that take hydrogen or ammonia. I don't want to get plumbers offside by promoting electricians who might put fuel cell and run an induction cooktop. Can you just talk a little bit about? I mean, it's a big space, isn't it? Lots and lots of variables. Who wants to kick off and just sort of pick that bigger picture about hydrogen as a fuel and ammonia as a transport vehicle? Is that the sort of thing that you're also looking at, Vikram, in the longer term or not?
We're sort of focusing on domestic applications,
yeah.
But in terms of exporting hydrogen, I think there are various pathways being looked at and trialed. So there is exporting hydrogen via liquid. And of course, there's a project right here in Victoria where KHI is sort of leading that consortium where they're making hydrogen from brown coal and liquefying it and then shipping it from the port of Hastings to Japan. So that's one route being tested. Then there's, of course, the ammonia route. And of course, ammonia is transported globally right now through there's established supply chain. So that's being tested. That's being tested as well. The challenge there is to take hydrogen back from ammonia out at the customer end. So it is some challenges there, and CSIRO has done a bit of research on that. So that's quite encouraging. And the third one is through a chemical, chemical transport. So Japan and Korea are testing and trialing all three, and all three options are open at this point in time. So there's no preferred option. All three are being tried. And in the domestic setting, as was mentioned before, even in Melbourne, we were running on Towns gas in the 50s, 60s, and 70s, and when we converted from Towns gas to natural gas. And people don't realize that now, if I'm sure most of us have gone to Hong Kong or Singapore, they're still on Towns gas, which is 50 to 60% hydrogen. So there is considerable expertise and knowledge about running appliances with very high concentrations of hydrogen right now. Large cities of Hong Kong and Singapore are on Towns gas. So we don't believe that this conversion process, because at some point in time, you'll have to go from a 5% or 10% blend to 100% hydrogen conversion. And it certainly it can be done, it's been done before. And it's a far cheaper option to go all electric because you've seen the huge interseasonal swing of gas consumption, particularly in winter.
Okay, so the questions about how long before we see 100% hydrogen, and there's questions about costs. Do you want to pick those up and go a little bit more deeply into comparative costs?
Yeah, so I'll answer the 100% hydrogen question first. I think the way our strategy is progressing is to achieve a certain blend of hydrogen where we achieve the scale of production, hydrogen production, which then lowers the cost. Right. And we think that's about 5 to 10%. If you can do that and do that well, what happens then is that we get the domestic use case, we get the appliances data, we get the customers on board, and more importantly, we get the cost down. Yeah. Because right now it's expensive compared to natural gas. But in Australia, we are really blessed with a lot of renewable energy resources, and their cost is coming down and down and down. So solar was like $100 a megawatt hour like 4 years ago. Now it's 50. It's projected to be 30. Yeah. That all of a sudden you're in parity with natural gas right there.
And wind the same. Yeah.
Exactly. And it's a perfect complement with the intermittency of solar and wind. And for example, in South Australia, I would suggest to you that at any given day when it's sunny and when the wind is blowing, there's about 200 to 300 megawatts of electricity just being curtailed or switched off. Yeah. Right. And all that power can be used for hydrogen.
Good work.
And it's a perfect complement for our energy system.
One for you, Emelia. When are the standards going to be made freely available?
And I might add to Emelia that, you know, the industry is moving really fast, right?
Yeah, yeah.
So we hope that the standards and the regulators,
Yeah.
who are traditionally slow, you know, they're about 5 years behind, but this is a real opportunity to keep pace.
Yeah.
Because we, you know, really want to build scale and domestic skills and capability.
Yeah.
So when when the Japanese come knocking at the door and say, "Now I want hydrogen," we are ready.
We're ready.
Yeah.
So you still haven't answered Emelia.
Get into that. So I think it's an interesting one, and it's probably a question that comes up at every conference that we speak at. But the story is changing, right? So with Standards Australia, we're in a cycle of transformation. You would have heard that we have a new CEO, that we've broken out of our publishing licensing agreement that we had for the last 15 years with SII Global, and we've brought a new distributor into the mix, so there is now competition. But I guess what I can say is that accessibility is at the core focus of our business, and getting standards out to our users and to plumbers and to people who do value our standards is at the forefront of that transformation. So while free standards seemingly appears to be unlikely, who knows what can happen, but I think the key thing is really that we're hearing the feedback that is coming through from our stakeholders on that issue, and that we are looking into how to make standards better accessible to our stakeholders. On Vikram's point about standards taking time and regulation taking time, that is definitely often a criticism of standards, that we take time. The good thing is that we don't just, standards are not the only solution. We have technical specifications which are peer reviewed that can be turned around quite quickly. But also, in particular with this hydrogen industry, what we're trying to do is we're trying to keep pace with industry and with government. And I think that's very, very key in the way that we're operating with the National Hydrogen Strategy, where they're ensuring that Standards Australia, that industry, that regulators, not just the Commonwealth, but states and territories, are actually being involved in that process. And I know Vikram mentioned the Future Fuels CRC. The work that they're doing is important. We're plugged into that work, and so as that the results of those testings become more available, we'll be able to work with them to see how we can actually incorporate some of those learnings into existing standards to be able to turn over that development quicker, so that we can be ready for when that demand does accelerate and take off.
A couple here for you, I think, James, but Vikram and Emelia may want to chime in. First is about the heat value of hydrogen. Do we need to change the sizes of pipes, or does it affect materials differently? And that may be something for Emelia. And the other one is about, for the comments made that, for example, natural gas produces carbon monoxide, so the safety issue. Are there any safety issues that we're going to have to refocus on as we shift to hydrogen?
Yes, regarding the heat value, the information that I have is hydrogen has more bang for your buck in terms of a molecular level. However, the gas is less dense. So in the end, it sort of comes out equal in terms of the performance of the gas. That's the information that I have. Some might say that hydrogen is better, but through testing, I think that it's comparable. Vikram, I don't know whether you have anything to add? Or
So the good thing is that most of the, not all, but most of the gas distribution networks are all plastic or PE, which work quite well with hydrogen. And as a matter of safety and upgrade, the old cast iron mains have been the program has been going on for the last 15 years, but the old cast iron mains are being progressively replaced by polyethylene pipes, which are, as it turns out, 100% hydrogen ready. So the distribution network should be able to use 100% hydrogen come early 2030s, But certainly the blending is fine, right?
Yeah.
So the real challenge to move from a blend of hydrogen to 100% is mainly on the appliance side. And I might add, on the large gas transmission pipes, hydrogen appears to be to cause embrittlement of the steel pipe. So that's an issue which the Future Fuel CRC is doing a lot of research on, and that remains an open question mark at this point in time.
And what about burning byproducts? Any new safety issues we need to take up with burning of hydrogen as compared to anything else? None?
No,
Okay.
it burns and
Okay.
it produces no carbon dioxide. It's only water and energy.
Simple
I guess
and
the down, so no carbon monoxide, but there is still the presence of nitrous oxides, which are considered a pollutant, and so you don't get rid of those because they're, in terms of that chemical equation, they're still in the atmosphere, and then we'll still be on the other side.
Okay. Now there's a question from Tristan. Is there, and I'll let you interpret the question, is there any development in point-of-use hydrogen generation and injection into the gas network, similar to photovoltaic electricity generation into the power network? Does that make sense to you?
Small scale, yeah. It is. There has been some research done on that, but I think it's at lab scale.
Any local fuel cells? Is that what I'm?
Just reverse process, right? Yeah. I think it's at pilot trial stage, but certainly there is some development, some theoretical development in that space. But it remains to be seen. I think it'll come down to a cost, and so what we are seeing is that large-scale electrolysis paired up with wind and solar large-scale, at this point in time, appears to be the most efficient way to make hydrogen.
Okay.
So I guess in terms of that graph as well, natural gas is still the cheapest option. And from an industrial, corporation perspective, there's no real incentive right now for people to start developing hydrogen products or rolling out hydrogen because there isn't, besides potentially little small-scale things. And that's where I guess the British government was looking, need to stimulate the economy to an extent to get the ball rolling.
Okay, a couple more. I think someone who's looking for a bit of work from you, Vikram. How are you managing the maintenance installation of the gas system at Mitchell Park?
The plant.
Yeah, or it may be, are the 710 premises ready? Do they need to be checked, maintained, or are the systems installed before they take the hydrogen?
Yes, so we have the area we've selected. We've carefully selected that area to ensure that the network is all plastic. The materials are all suitable for blended gas, so we've done that. We are putting in place some additional precautions of leak surveys and safety checks. That's part of our safety case with the Office of the Technical Regulator. So we've developed a more stringent sort of safety maintenance regime just for that network, just to be sure. But at a 5% blend, it's no different to natural gas. It should be no different to natural gas at that small blend. But what the project does, it gives us some real data on appliances and gets the community buy-in, so that helps us scale up.
Okay.
When we look at, I guess, standards as well, because having some form of demonstration take place to actually see what is trialled and what is tested, what works, what doesn't work, will then assist us in forming the basis for revisions or amendments to standards that will then be necessary.
There's a question just come in which I think is for you. Standards Australia working with Standards New Zealand on the current hydrogen plan?
So with the way our projects work, there is an opt-in, opt-out process. At the moment, our technical committee are primarily mirroring the international work. However, when we start looking specifically at standards that are either joint standards or even standards that are currently just AS only, there will be an opportunity for Standards New Zealand to take part in that. What's key is that the members on the committee there are members on the committee who are aware of what's going on in New Zealand, because they're actually quite ahead as well in terms of some of the work that they're doing. But as there are no real active projects taking place, we haven't readily or actively engage them, and we will do that when we do have an active project in place.
Okay. There's a couple of questions here that relate to the ratio of hydrogen to natural gas, and one is sort of, wouldn't it be, is it better just to go straight to 100% hydrogen for industrial, or what's the flip over point? So what's the ratio at which stage you go to 100%?
Yes, that's an open question. I think, and all the testing data will give us that answer or some sense to that, because we are testing the appliances for higher and higher blends of hydrogen and see where that point is. But I suspect at this point in time, it's around the 15-20% mark. Certainly there are trials in Germany and in France where they're injecting about 10 to 15% blended hydrogen into networks, but their appliances are slightly different to our appliance. You know, the pressure regime is slightly different. But we think it's around the 15% mark. So at some point in time, we'll hit that limit, and then it's about pausing and then really developing a planned national strategy for conversion.
Yeah, okay. Now, one more question. I think this actually goes to Shane Lecombre. Shane, it says, the question is, has any consideration been given to retraining typo plunders and support to RTO for training of apprentices in the space?
Yeah, great deal. I think one of the things that we've seen is many advances, many initiatives, many shifts in terms of taking advantage of new technology have been stifled or at least set back because you haven't got a workforce to come in behind and do the jobs that need to be done. So one of the things, and really applaud Standards Australia here, we've been as an industry in discussions with Standards Australia talking about this works great, and the boffins and the prop heads are right on it, but what's happening with training if we go in a certain direction so that we're ready for boots on the ground? And to that end, training has been rolled into input in terms of how these standards are being reviewed, and I think that's for once we're getting that up front, and I think that's tremendous.
Yeah, great. Great questions, ladies and gentlemen. Thank you for those. Would you please thank our panel, Vikram Singh, Emelia Addo and James Kelly.